Fusion energy is a potentially revolutionary source of power that has long been pursued as a cleaner, safer, and more sustainable alternative to traditional fossil fuels and even other forms of nuclear energy. At its core, fusion is the process of combining two light atomic nuclei to release an enormous amount of energy. This process powers the sun and stars and holds great promise for addressing our global energy needs while minimizing environmental impact. In this detailed overview, we'll explore the science behind fusion, the current state of fusion research, and its potential benefits and challenges. The science of fusion. Nuclear fusion. Fusion occurs when two light atomic nuclei, typically isotopes of hydrogen, such as deuterium and tritium, combine to form a heavier nucleus. This fusion process releases a tremendous amount of energy in accordance with Einstein's famous equation, E=mc², where a small amount of mass is converted into a large amount of energy. E=mc², where a small amount of mass is converted into a large amount of energy. The fuel cycle. The most widely studied fusion reaction for practical energy production is the combination of deuterium, D, and tritium, T. Deuterium is abundant and can be extracted from water, while tritium can be bred from lithium, which is also relatively abundant. Extreme conditions. Achieving fusion on Earth requires creating extreme conditions of temperature and pressure similar to those found in the core of stars. These conditions, typically in the range of tens of millions of degrees Celsius, cause the fuel to become a high-temperature plasma, where atomic nuclei collide with enough energy to overcome electrostatic repulsion and fuse together. Current fusion research. Magnetic confinement fusion, MCF. This approach uses magnetic fields to contain and stabilize the high-temperature plasma. The most notable MCF device is the tokamak, which uses a donut-shaped magnetic field to confine the plasma. The International Thermonuclear Experimental Reactor, ITER, is a massive tokamak project under construction in France, aiming to demonstrate the viability of sustained nuclear fusion reactions. Inertial confinement fusion, ICF. In ICF, powerful lasers or ion beams are used to compress and heat a small pellet of fusion fuel, causing it to undergo fusion. The National Ignition Facility, NIF, in the United States is one of the leading facilities working on ICF. Alternative approaches. There are several alternative fusion approaches, including field-reversed configuration, FRC, spheroMAC, and laser-driven inertial fusion, which are being explored by various research institutions and private companies. Advantages of fusion energy. Abundant fuel supply. Fusion relies on isotopes of hydrogen and lithium, which are virtually inexhaustible and widely available. Clean and safe. Fusion produces minimal radioactive waste and has no risk of a catastrophic meltdown, making it inherently safer than fission reactors. No greenhouse gas emissions. Fusion releases no greenhouse gases, contributing to efforts to combat climate change. Continuous power generation. Unlike intermittent renewable sources like solar and wind, fusion can provide a stable and consistent source of power. Challenges and remaining hurdles. Technical challenges. Controlling and sustaining the high-temperature plasma is a significant technical challenge. Researchers must find ways to maintain the conditions for fusion while dealing with materials that can withstand extreme heat and radiation. Economic viability. Developing fusion technology to a practical and economically competitive level is a major hurdle. Building and maintaining fusion reactors are expensive endeavors. Regulatory and safety concerns. Fusion reactors will need to meet stringent safety and regulatory standards. The road ahead. Fusion energy holds immense promise, but it remains a long-term prospect. It will likely be several more decades before commercial fusion power plants become a reality. Research efforts, including international collaborations like ITER, are essential to advancing our understanding of fusion and overcoming technical challenges. Private companies, including startups like Tri-Alpha Energy and TAE Technologies, are also actively working on fusion and may play a crucial role in the future development of this technology. In conclusion, fusion energy has the potential to provide a nearly limitless, clean, and safe source of power that could transform the global energy landscape. While significant challenges remain, ongoing research and development efforts are bringing us closer to harnessing the power of the stars for practical use on Earth, promising a brighter and more sustainable future for our planet.